An event is something that happens at a single point in space, at a single instant in time. A flash of light, a collision, a particle decaying. Each one is a dot in space-time. Today, let's talk about what observers must agree on and what they don't have to agree on. First of all, what is an event? Imagine you're at position x equals 0 at time t equals 0. You turn on a flashlight for an instant. That flash right there, right then, is one event. Special relativity makes a very important claim. All observers, no matter how fast they're moving, must agree on whether an event happened. You might disagree about the coordinates of that event, its time or its location in your frame, but you cannot disagree about its existence. If a flash of light occurred, everyone in the universe must agree that it occurred. But what about sequences of events? Where things get tricky is when we talk about two events. Observers must agree on the existence of each event, but they do not have to agree on the time between them, the distance between them, or even which event happened first. This is where relativity truly earns its name. Let's build a simple scenario. Two mirrors are fixed to a train car. The train is moving smoothly past a person standing on the platform. Inside the train, a light pulse is emitted from the middle and travels to each mirror. For someone riding on the train, the light travels equal distances left and right. The reflections at the two mirrors happen at the same time. To them, these two reflections are simultaneous events. But the observer on the platform sees something different. From their point of view, while the light is traveling, the train is moving. So the mirror in the front of the train is moving away from the light, and the mirror at the back is moving toward it. The result? The reflection at the back mirror happens first. The reflection at the front mirror happens later. Both observers agree there are two reflections. They agree on where each reflection physically takes place, each at its own mirror, but they do not agree whether these two reflections were simultaneous. Now let's address a common misunderstanding. Could one observer claim that the light hit the front mirror while another claims it missed it entirely? No, that would mean they disagree on whether an event happened. And special relativity does not allow that. If a photon strikes the mirror, if that interaction physically occurs, every observer must include that event in their space-time description. They may assign different coordinates to it, but the event itself cannot disappear or appear depending on who's watching. This is essential for preserving causality and for ensuring that physics is consistent across reference frames. So here's the summary. Events are the fundamental points of space-time. All observers must agree on whether an event happened. They don't have to agree on coordinates, distances, time intervals, or simultaneity. Even with something as subtle as light traveling in a moving train, everyone still agrees on what happens, just not when. Special relativity doesn't change reality. It changes our description of reality, depending on how we move through it.